Hey everybody, welcome back to Mr. A's Geometry course. Today's video is going to be the second part of section 3.5, which is all about the equations of parallel lines. Let's get into it. Hopefully you recall from algebra, one of our common equations of lines is called the slope-intercept equation. So this is an equation for any straight line that is in this form, y equals mx plus b, where the variables that are involved here in this equation stand for the following things. M is your slope, B is your y-intercept, so that's where your line crosses the y-axis, and the x and the y represent the x-coordinate and y-coordinate of any point that may exist on that line. What's really important from our slope-intercept equations is that we can identify the slope and y-intercept of any given line. So a few examples of that over here. We have an equation y equals 3x plus 4. And this is typically how every slope-intercept equation is presented. We have x and y as constants, so there's no numbers substituted for those, but we do get numbers substituted for the m and the b, and that's how we're able to identify the slope and the y-intercept. So because there's a 3 where the m is supposed to be, that means the slope is 3. Because there's a -4 where the b is supposed to be, that means the y-intercept, or where it crosses the y-axis, is at -4. We will often see slopes as fractions. So we see that 3/4 here where m should be, so that's a slope of 3/4. We have a +10 here where the b should be, so that's the y-intercept where it crosses the y-axis at +10. So let's make sure we have this foundational skill set, right? Let's look at all these equations here that are slope-intercept equations and see if you can solve for or find the slope and y-intercept for each of these lines. Go ahead and pause the video and see if you can do that on your own. Okay, let's see if you got the correct values. Our first line is y equals 3x minus 9. So we have a 3 there in front of the x. That'll be the slope. Slope is 3. The y-intercept then follows our x. This is a -9 here because it says -9. So slope of 3, y-intercept of -9. Our next line is y equals 7/8 x plus 10. We will often see our slope as fractions like that, 7/8, and we have a +10 after for our y-intercept. Right, we have an equation here, y equals -10x minus 2. So that's a -10 in front of our x, that's our slope. We have a -2 after, that's our y-intercept. Then that last equation is still a slope-intercept equation. That value in front of x is still our slope. That's -5/7. Notice there's nothing after x, so that means the y-intercept must be a 0. That's the number that represents nothing. Also, just be aware, sometimes your slope-intercept can be a little scrambled, so you could have something like y equals 5 minus 2x, which would be no different than y equals -2x plus 5. Right? So just be aware, sometimes it could be a little bit out of order there. The y-intercept would be 5, the slope would still be the -2 there in front of our x. A large part of our lesson today is going to be writing the equations of lines in slope-intercept form. And we're going to need 2 pieces of information in order to do that, right? The most common pieces of information that we're going to need is the slope of a line involved, and then we need to know the location of any point that's going to exist on our line. And if we have a slope and a point, we can use the slope-intercept equation y equals mx plus b to figure out what the y-intercept of our line is going to be. Remember, that is the b in the y equals mx plus b. So we'll show you how that's done here in our first example. So we're going to see here in this example that all I need is a slope and a point on a line, and I can write a slope-intercept equation for that line. So the first thing we need anytime we're writing the equation of the line is the slope, and we're just straight up given it here. It's the slope of 4/5. Remember, we use the letter m for the slope in our slope-intercept equation. So I know my m is 4/5. Now remember, any point has an x-coordinate and a y-coordinate. So this -15 is an x-coordinate that exists on my line, and this 1 is a y-coordinate that exists on my line. And I'm going to take these values now and use them in the slope-intercept equation to solve for the y-intercept of my line, because that's the only thing that I don't know about it right now. So I'm using y equals mx plus b, and I'm plugging in all this information into that equation. So my y is +1, so I'm going to substitute that +1 on the left side of my equal sign. I know my m, my slope, is 4/5, so I'm going to substitute that for the m in this equation. And I know that my x is negative 15. So I'm going to substitute that in here. I would have to put parentheses like this to show that because we're doing slope times x here. And then we notice the only thing that's left unknown now is the b. So I can just do algebra here and actually solve for this y-intercept. So we're multiplying 4/5 times negative 15 there on the right. And remember, this is how I like multiplying by fractions. I would take the negative 15, multiply it by the numerator of 4, and then divide by 5. So I do negative 15 times 4, which would give me negative 60, and then divide negative 60 by 5, which would give me negative 12. Be very careful with your signs here. A lot of students will mess up their positives and negatives as they're multiplying, so be careful with that. 4/5 times negative 15 gives me negative 12. Now I can get b alone by just using my addition property of equality here. I can add 12 to both sides of the equal sign to get b by itself, which is 13. And from this information, I can write the equation of my line. So remember, the slope-intercept equation has a constant y, it has a constant x. What we had to fill in is what is the slope of our line and what is the y-intercept of our line. And we have those things now. We already knew from the beginning that our slope was going to be 4/5, so we have 4/5 x. And then we just solved for the y-intercept. It's positive 13, so we have plus 13. That would be the equation of this line. Here's a chance for you to practice that on your own. Pause the video and see if you can write the equation of a line with a slope of negative 2 and containing the point 60. Okay, let's see how you did. Remember, the first thing we need is what is our slope? And we're told here the slope is negative 2. So no work needs to be done there. We have a point, an x-coordinate and a y-coordinate that needs to be on our line, and we're going to use that and our slope of negative 2 to find the y-intercept. And remember, we do that with our slope-intercept equation, y equals mx plus b. We're just subbing in information. Instead of y, I'm writing my value for y, subbing it in at 0. Instead of m, I'm writing my value for m. My slope is negative 2. Instead of writing x, I'm subbing in my x-coordinate, which is positive 6. And then we still have the plus b that we can now solve for our y-intercept. So we have our 0 on the left side of our equal sign, then we have negative 2 times 6 is negative 12. You can be very careful when you're dealing with our negatives here, please. Now I can get b alone now by adding 12 to both sides of the equal sign, and I get a y-intercept of 12. So slope's negative 2, y-intercept is 12. The equation would then be y equals negative 2x plus 12. Remember, we have slope here, y-intercept here. The y and the x stay constants when we write the equation of a line. We're now going to take this information to learn how to write the equations of parallel lines. And really the only thing you need to know now in order to do this is what happens with the slopes of parallel lines. And here it is. Make sure that we are memorizing this. Parallel lines have the same slope. If you think about it, it makes sense. Parallel lines stay the same distance apart. They never intersect, so the rise and run of the lines has to be identical in order for them to stay the same distance apart. What we're going to do now is make sure that you can identify the slope of a line that is parallel, right? So if you've given an equation of a line and we want to write an equation of a line that's parallel to it, our fact here tells us they need to have the same slope. Okay, so if we identify the slope of this line, then we've identified the slope of a parallel line. The slope of y equals 3x minus 9 is 3. So a parallel slope would be exactly the same. It would be 3. And that's just my little symbol there of saying this is a parallel symbol. A parallel slope's got to be the same. It has to be the same value. Okay, so again, the slope there is 3. The slope for this line gives that fraction in front of x, it's 7/8. And parallel lines have the same slope. So when I write the equation of a line parallel to that, I'm also going to have 7/8. And so on. The slope of this line is negative 3. So a line parallel to it will also have a slope of negative 3. The slope of this line is positive 3. So a line that's parallel to it will have the same slope of positive 3. Parallel lines have the same slope. So let's put our information together now. We are going to write the equation of a line that is parallel to y equals 2x minus 6. And our line is going to contain the point +1, -3. Well, just like we did before, the first thing we need to do is determine the slope of our line. So the slope of this line, again, just the value in front of x. So we can see here that the slope is +2. So our slope for our line, because it's parallel, we just need to recall parallel lines have the same slope. So our slope also going to be 2. Remember, the point that's given to us has an x and a y coordinate. We're going to use those along with our slope in our slope-intercept equation to solve for the y-intercept, to solve for that b. So we're using y equals mx plus b, and we're substituting our values in. So we have a y of -3, that's going right here, -3. Okay, we have a slope of 2, that's going to sub in for our m, 2. We have an x-coordinate of +1, that's going to sub in for our x-coordinate there, +1. And now the only unknown in our slope-intercept equation is the y-intercept. All right, so we're doing our algebra now to solve for b. We got -3 on the left. We have 2 times 1, which is 2, plus b. Now we get b alone by using our subtraction property of equality here. We subtract by 2 on both sides. We would get a y-intercept of -5. And we can now write our slope-intercept equation, because remember, what we need is the slope and the y-intercept, and we can write any slope-intercept equation for a line. So y is a constant equals m, which we know is 2, x is a constant, and then plus b, our b in this case is -5, so we would just write -5. This would be parallel to y equals 2x minus 6. Here's a chance to see if you can do this on your own. Go ahead and pause the video and see if you can write the equation of a line parallel to this one containing the point 12, 0. All right, let's see how you did. We need to first identify the slope of the line that is parallel to ours. And that, again, is just the value in front of x. That's -2/3 for this line. Our line needs to be parallel to this one. We need to have memorized that parallel lines have the same slope. So a line parallel to this one will also have a slope of -2/3. Again, we have a point on our line that's an x-coordinate and a y-coordinate. We're going to use those and this slope to find our y-intercept from the slope-intercept equation, y equals mx plus b. So we're subbing our 0 for our y, we're subbing our -2/3 for our m, we're subbing our 12 for our x. And then we're doing algebra to solve. Remember to multiply by a fraction. You're going to take your number, multiply by the numerator, and then divide by the denominator. So we have a positive times a negative here. We're going to end up with a negative result for multiplying. 12 times 2 is 24. 24 divided by 3 is going to give us 8. So we get -8 as a result of positive 12 times -2/3. Now to get that b by itself, we're going to use our addition property of equality. So we're adding 8 to both sides. We get a b of 8. Now we have what we need. Slope's -2/3. The y-intercept is +8. So y equals -2/3 x plus 8. We're going to add a layer to this now and talk about the standard form equation. So this is a different form for the equation of a line. We have the slope-intercept y equals mx plus b. The standard form equation is ax plus by, that's a b, so sorry for my handwriting, plus by equals c. And really a great way to think about the standard form equation is just a scrambled version of the slope-intercept equation. Now there's lots of stuff that can be done with your standard form equation. There's ways that we can think about equations by staying in this form, but I think it's going to be better for you in the long run to learn how to just change this back into the slope-intercept equation. So that's what we're going to work on here first. We're going to rewrite this standard form, ax plus by equals c, and we're going to rewrite this in the slope-intercept form. And the way that you do that is just by solving for y. So you treat this like an algebra problem where you want y alone on the left side of the equal sign, because that's what the slope-intercept equation looks like, right? It's y on the left and then your x and your y-intercept on the right side of the equal sign. So to do that, we're treating it again like an algebra problem. I want the y alone, so I'm going to get rid of all the stuff that's on the same side of the equal sign. So I can start with that 3x. I can move that to the other side of the equal sign by subtracting 3x from both sides. So my 3x's cancel on the left to leave me with just 5y. On the right side, I have, these are not like terms, so I have negative 3x and positive 12. And just like our slope-intercept equation, we want that x thing to come first right after the equal sign. So I have negative 3x here, and then the positive 12 after. And then now I can get y alone by dividing both sides by 5. Now when I do this, when I divide by 5 here, I have to divide everything on the other side of the equal sign by 5 as well. And I think maybe the best way to think of this is each individual term gets divided by 5. So that term gets divided by 5, this term gets divided by 5. And so the result here is that the 5's cancel on the left to leave me with just y. And that will equal, then we have a negative 3 over 5, negative 3/5 x. And then we have plus, we can leave it as 12/5, you can write it as a decimal, it doesn't really matter to me because the key thing in what we're doing here is going to be able to determine the slope after we get it in slope-intercept form. So this will be the same equation in slope-intercept form instead of standard form. We're gonna do this again. We're gonna go from standard form to slope-intercept form. We can notice though in this example though that sometimes standard forms are a little tricky because even though the technical equation is ax plus by equals c, you'll notice that the y comes first here and the x comes second here on the left side of the equal sign. So we just need to be careful and remember that the slope-intercept equation is the y alone on the left side of the equal sign. So I can still get this to that slope-intercept form. I just need to be careful with what I'm moving. I need that y alone, so this is going to be the term that I move to the other side of the equal sign. I can add 2x to both sides, and so that leaves the negative 3y on the left. The 2x's cancel. And I have a positive 2x first with a minus 10 after on the right now. And I can get y alone from here by dividing both sides by negative 3. And again, we need to do that to every term on the right side of the equal sign. So that gets divided by negative 3. This gets divided by negative 3. Negative 3's cancel on the left to leave me with just y. Then I have a 2 over negative 3. Maybe the best way to think about this is it's a negative slope because a positive divided by negative gives you negative. So it's a negative slope of 2/3 x. And then we have negative 10 divided by negative 3, and negative divided by negative is always a positive, right? And I can leave that as a fraction or write it as decimal, doesn't matter. This is the slope-intercept equation for this line. Okay, we're putting this together now by writing the equation of a parallel line, but the line that we're given is in standard form. So we're gonna turn that into slope-intercept form and then do the same thing that we did in our previous examples, right? So I need to determine the slope of this line. Well, the first thing I'm gonna do is convert that to slope-intercept form, right? So the equation I'm starting with is 8x minus 4y equals 16. Remember, to get this to slope-intercept form, we're just solving for y. So I need to move that 8x away onto the other side of the equal sign. I'll use the subtraction property of equality to do that. So I'll have the negative 4y on the left still, and I'll have a negative 8x and a positive 16 on the right. Now I can get y alone by dividing everything by negative 4. This gets divided by negative 4, this gets divided by negative 4. The negative 4's cancel on the left, leaving me with just y, which is exactly what we need. Then we have a negative 8 divided by a negative 8, divided by a negative 4, which would give me a positive 2 there in front of the x. And then we have positive 16 divided by negative 4, which gives me a negative 4. And remember, the only thing that matters for this line is what is the slope, because our line needs to be parallel to this one, and parallel lines have the same slope. So the slope of that line is 2. All right, and this is really the only difference in this example and the ones before. We just had to convert to get here. Now it's exactly the same as our previous examples. If the slope here is 2, and we're writing the equation of a line that's parallel to it, well, our parallel line will have the same slope of 2. We have this point given with an x-coordinate and a y-coordinate, the positive 5 and the negative 2. And remember, that's going to plug into our slope-intercept equation for us to find out what our y-intercept is going to be. So that negative 2 gets plugged in for our y, negative 2, do my line here. That slope of positive 2 gets plugged in for our m, so we have positive 2. That x-coordinate of positive 5 plugs in for our x, so we're doing times 5. And now the only unknown in that is our b, and we can solve for that. So still -2 on the left. We have 2 times 5 on the right to give us +10. We get b alone now by subtracting both sides by 10. We get a sloped intercept of -12. And again, we've determined the slope of our line needs to be 2. And we've determined our y-intercept is -12. So we can now write that equation. Y equals m, which we know is 2, x plus b, and our b is -12, so -12. That would be the line parallel to that standard form equation. Remember, the idea here is if we're given standard form, we need to convert it to slope-intercept so we can identify the slope. Okay, then we can plug that in with our given point into y equals mx plus b to find our b-intercept, or y-intercept, and then write the equation of our line. In this next example, I forgot to give us a point for our line. We got a standard form equation here. Let's say a point that's on our line is going to exist at, we'll say +3, -4. Okay, so we're gonna write a line parallel to this one containing that point. Remember, the first thing that we're gonna do is convert. So we need to take that standard form equation and get it in slope-intercept form. So we have 3y plus 7x equals -7. Remember, the idea here is to solve for y. Get y alone on the left side of the equal sign. So I'm going to move that 7x by subtracting 7x from both sides. That leaves me with the 3y on the left equal to -7x minus 7. And I can get y alone now by dividing everything by 3. And so I get y on the left equal to -7/3x minus 7/3. The slope of that line is -7/3, and since we're writing the equation of a line parallel to this one, we need the same slope. So our parallel slope is also going to be -7/3. Now I can take that x coordinate of 3, that y coordinate of -4, plug those into the slope-intercept equation to solve for the y-intercept of my line. So y is -4 equal to our m, which is -7/3 times our x, which is 3, plus b. To multiply by that fraction, we're doing 3 times 7, then divided by 3. And we have a negative fraction here times a positive value, so we're going to get a negative answer here. 3 times 7 is 21. 21 divided by 3 will give us 7. So 3 times -7/3 will result in -7. I can get y-intercept alone now by adding 7 to both sides. -4 plus 7 gives me +3. So I know my slope needs to be -7/3. My y-intercept needs to be +3. So my equation would be y equals -7/3 x plus 3. Guys, that wraps up our lesson today on the equations of parallel lines. Our next video will all be about the equations of perpendicular lines. We'll see you when that time comes, guys. Bye.